So hello guys, welcome to my YouTube channel again, and today we will be discussing the question of today's daily challenge, that is 4th Feb, and the question name is permutation in string. So I'll advise you to first go through the problem and try it yourself and then see the video editorial. So now I'm assuming that you have given enough time to this, and yes. So let us discuss the question statement first. So here you will be given two strings s1 and s2, and you have to return true if s2 contains a permutation of s1, otherwise false. Basically this s1 is a smaller string and this s2 is a bigger string, and you have to tell whether there exists a substring in s2. That substring will be of size same as s1. So whether there exists a substring in s2 of size 2 which is a permutation of this ab. So here we have returned true because this ba is a permutation of this ab and it is one of the substring in s2. Okay, so you just have to return true or false. So this is the question. You can go through the other samples as well, but this is the question. Basically the bigger string is s2 and you have to find whether there exists a substring in s2 which is a permutation of s1. So yes, so now let us move with the solution for this. So the brute force solution for this will be simple, that try to check for every substring. First thing is that how to check whether a particular string, suppose I am giving you two strings, string 1 and string 2, and you have to check whether string 1 is the permutation of string 2. So how you will check? So in order to check whether one string is the permutation of string 2, what you can do is, see, if I am saying ABC and if I am taking any permutation of this, so it will either be BCA, it can either become CAB, like it can be anything, but the thing is the characters will remain the same. So in permutation the characters remain the same, so the frequency of every character basically remains the same, because permutation is just the arrangement, numbers do not change, like characters do not change. So basically in order to check whether two strings are permutation or not, you can basically check the frequency of each and every character, and if for every character the frequency is same, then you can say that one string is the permutation of the other string. So yes, for the brute force solution we will just do whatever is told to the question. So we will, whatever is told in the question, so what we will do is, we'll check for every permutation, check for every substring and check whether this substring is a permutation of s1 or not, and we will do it by making use of frequency. As I have already told you, frequency of every character remains the same. So frequency basically all our lowercase letters, let me also check, so contains all our lowercase English letters. So we just have to check for 26 characters, and yes, so I'll make a map for this to check whether the frequency is same or not. Okay, so first let us make the map of s1. Basically map of s1 means all the frequencies that are there in s1. Okay, frequencies of s1. So map of, you can also make an array of size 26, that will also work fine. Okay, basically there are 26 characters, so array of size 26 will also work. So for auto x to s1 map of x plus plus. So this map now stores the frequency in s1, and now we'll iterate over all the substrings, of size equal to s1 dot size. So we have to check all the substrings of size s1, like all the substrings of s2 which are having a size equal to this. Okay, So suppose I'm giving you one example string a b c d e f g. It is of size 7. So the indexing, if you try to do the indexing of this, it will be 0 1 2 3 4 5 6. And if I then tell you to iterate over all the strings of size equal to 3, so size is equal to 3. So how will you do? This is the first string, so the starting character, this is the first substring, the starting index of it is 0, the ending index is 2. Second is this, starting index 1, ending index 3. Third is this, starting index 2, ending index 4. Then there is this, starting index 3, ending index 5. And then this is the last one, starting index 4 and ending index 6. So if you look at the starting index can be just the string length. What is the string length? The string length is 7. So the starting index can be at most n minus size. It cannot exceed n minus size. That is, from the 5, as taking 5 as starting index, you cannot find a string which is of length 3. So it is nothing but n minus the starting point can be n minus sz. Sz is the size of the substring you have to find, and n is the size of the entire string. So we'll just iterate over that. Okay, so what we'll do is, for int start is equal to 0, start less than equal to n minus sz, start plus plus. So this is the starting point. So if you have seen that if the starting point is 0, the ending point is at a distance, like from going to this we have to increment 2 steps. So 0 plus 2 is 2. So you have to increment sz minus 1 times to get the ending index. So int end is equal to start plus sz minus 1. Sz here, sz is the size of this s1, because we have to find a substring which is of size s1. Okay, so here int sz will be nothing but s1 dot size, and n will be nothing but s2 dot size, because s2 is a bigger string and sz is the smallest string, whose substring we have to check, like whose same size substring we have to check in s2. So then we have got the start and end. Then we can just create a map for this. Okay, character comma int, this is the map substring, map sub, and then we iterate from this. Then we iterate from start to end, start, then we iterate int j is equal to start, j less than equal to end, j plus plus, and map sub of s2 of j plus plus. Basically we are in the second string, s2 string, and we are making the frequency. Okay, then we'll check for all characters in MP whether it is having the same frequency in the second map, like map of substring. So if for all the characters in MP the frequency of every character in MP and in MP sub is same, then you can say that yes, this particular substring is valid. So let us directly iterate over the map MP. Here the character will be s dot first and its frequency will be x dot second. So this is a way to iterate in the map. So character ch is equal to x dot first and its frequency will be x dot second. So now we'll check this particular character frequency in MP sub. So if it is not present, then it will directly give you 0, because this is a property of map that if something is not present in the map, it gives you 0. So you don't have to write some check condition that whether this character is present in the map sub or not. It will directly handle that case also. So if map sub of this character is not equal to, so you will make one check Okay, int check is equal to 1 means everything is valid, and as soon as you get something invalid, mark that as invalid. Okay, so if it is not equal to the frequency, then we have found a negative case, so you can directly do check is equal to 0 and break. So if you found even a single character where the frequency in the original map and map sub is not equal, so you will directly do check is equal to 0 and break. But if not, then the check one will, like the check value will be 1, that means it is valid. So if check is equal to 1, then you can directly return true. Okay, because we have found one of the substring. And if after processing every substring we haven't found the answer, then you can return directly false, that is we haven't found our answer anywhere. Okay, so this is the brute force approach. Let us also test this. Yes, so it is working in samples. Yes, it is working, but you can see that in terms of time complexity and in terms of space complexity also we are far behind. Okay, so yes, this is the brute force solution for this question. Okay, so coming to the optimized solution, so this is the brute force one. Okay, I'll also paste it here. If you want to know the time and space complexity of this, let us also analyze that. Okay, so the time complexity of this is, see, we are iterating from, like, this is O of n loop, and inside the O of n loop we are also iterating from start to end. So this is, in worst case, this can be also O of n, so this can also be O of n, and it is O of n outside, so the time complexity of this will be O of n square. And the space we are not using, we are just using a map which will be maximum of size 26, so you can say that it is just a constant number. 26 is a constant number here, it do not depends on n. Okay, so here you can say that the time complexity, and I am also neglecting that term of log 26 because log 26 is also constant. Okay, so it is because in the map if we try to retrieve things, it takes log n time, so log of 26, but this 26 is a constant, so you can neglect this as well. Also this if you can avoid this, if you are using n frequency array of size 26, so that is also fine, so this is not needed. So the time complexity is just n square, and the space which we are using here is O of 1. Okay, so the space which we are using here is space complexity is nothing but O of 26, or you can roughly say that it is O of 1. Okay, so this is it for the brute force solution. Now let us optimize this solution further. Okay, so yes, so in order to optimize over this solution, what we have seen is in the brute force solution we were iterating for every substring from the start. Like suppose this is one substring, then this is the second substring. So in order to find the frequency of all the characters in the second substring, I was iterating over the second substring again. For the third substring, I will be iterating over it again. So what we can do here is, instead of iterating over a particular string each and every time, see, we will just observe what are the things that are changing when I move from the first substring to the other substring. Okay, so let me bring it here. So here see, this is an example 0 1 2 3 4 5 6. So let us consider a 7 size substring A P A C, again B C E, and we have to, like, the string 1 dot size is 3, so we have to check for every substring of size 3. So here if you consider the first, so this is the string given to you. Here just consider the first substring, like the first substring of size 3. So here if you consider it, it is something like this, and if you consider the second substring of size 3, only thing which is changing is that this element is being added and this element is being removed. Okay, this is the only change which is happening. The between characters remain the same. So what we observe is we don't have to iterate again and again. We will use something like sliding window technique here, in which every time the last character we take that into account and remove the first character from the previous window. So you can consider that in this second example also. For the second substring, this B is being added and this B is being removed. Okay, so this is a basically sliding window problem, where we observe that if we slide from one window to other, only element which we have to add, we add that, and we remove the element which is present at the start of the previous window. So we'll try to code this, and we'll like, this is a standard sliding window, fixed size sliding window approach. Okay, so here also, so first we have to make the initial map of S1. We have to make it because we have to compare every time. Whether map sub has become equal to the map, like that particular substring map has become equal to the original map or not, because we have to check for permutation. Okay, so first we'll make that map character comma int map, then for auto x in S1 mp of x plus plus, then we take n as s2 dot size, and then we take sz is equal to s1 dot size. So this is the sliding window, this is that length of the sliding window. Okay, so in sliding window questions, first we have to take care of the first window. So this is the standard sliding window that we do in every question. First consider the first window. So how to consider the first window? So the first window will be nothing from 0 to if we want to find 3 size windows, so it will be from 0 to sz minus 1. So for int j is equal to 0, j less than sz, j plus plus, and we'll maintain one map sub map of character char comma int map sub, and we'll maintain the frequency of this window in the map sub of str s2 j plus plus. Okay, so this is the first window. Then we'll check for the first window whether it is equal or not, because this is every time, like first window we have to check manually, and we also have to check whether the first window is valid or not. So we are checking whether the first window is valid or not. So for that we will directly iterate. So the same thing which we did in the brute force solution, we'll maintain one check is equal to 1. Check is equal to 1 means everything is valid till now. Then for auto x is equal to mp, the character we will get using x dot first, and its frequency we will get using x dot second. Then after doing that, what we'll check whether in the second map the frequency of that character is equal to the frequency in the map. So if it is, then it is fine. If it is not, then we can directly do check is equal to 0 and we can break. So if check equal to 1, that means that the first window was itself valid, we can directly return a true, that we have found a valid window. Otherwise the first was not valid, so then we apply the sliding window and we slide to all the subsequent windows from the previous window. So this was the first window. Then how to move from the first window to the second window? Just take into account this character and remove this character. So we'll iterate over this ending point. Okay, the ending point can be either 3, can be either 4, can be either 5, can be either 6. So for the second window the ending point will be 3, for the third window ending point will be this 4, and then it will be 5, then it will be 6. So what we do here is we iterate over the ending point. End is equal to sz, end less than n, end plus plus. So for this window we have this end. Okay, so how, like, suppose this is the end. Okay, this 3 is your end. So what is the starting point of this particular window? So the starting point is nothing but from the 3 we subtract sz minus 1. Like from the 3 we subtracted 2 to reach this 1, right? So sz is 3, so we subtract 2. So for this window the start will be sz end minus sz minus 1, and from the previous window what we have to do, we have to add end and we have to subtract add and we have to remove end start minus 1. So see, if we are at a particular window, okay, if we are at this particular window, so the end is this 1 and the start is this end is this 3 and the start is this 1. So if we are moving from the previous window to this window, then what will happen, we have to take this end into consideration and we have to remove this start minus 1 from the previous window, because now the map, like here the MP sub contains the previous window. Okay, contains the previous window. So in order to move from the previous window to the current window, we have to remove the character start minus 1 and we have to add the character end. So we'll directly add in the map sub of s2 of end plus plus and map sub of s2 start minus 1 minus minus. So this we are adding, here we are adding the start end and here we are removing the start minus 1th character. So now we have moved successfully moved from the previous window to the next window. So now we'll check for this particular window whether this particular window is a permutation of S1 or not. So for checking, code remains the same. Also what you can do is you can make one more function for this checking function and it will return true or false depending on whether the two frequencies are same or not. But for now I'm just writing it here, but it is better if you do that way. So check is equal to 1 valid, then we move to this and we check whether that particular frequency is same. If it is same, then we directly return true. If at any point I get a check is equal to 1, that is I get a valid case, I'll directly return a true. At the end, if we haven't found any answer, then we'll return a false. Okay, so let us also test this thing. Okay, so let me check. Okay, so let me check. We have taken map, then we have iterated over S1, we are increasing the frequency n is nothing but s2 dot size, sz is nothing but this, map sub from 0 to sz. We are incrementing the frequency in the map to s2 dot j plus plus, then check is equal to 1. We are iterating over the map. Dot first contains the character and dot second contains the frequency. Then we are checking in the map sub, we are checking whether that particular frequency, if it is not equal to the frequency, then we do check is equal to 0 and break. So if check is equal to 1, we directly return that, and end is equal to sz, and end is equal to sz, end less than n, end plus plus, and start is nothing but end minus sz minus 1. So we do 3 minus 3. Okay, it is nothing but it is plus 1 here. So 3 minus 3 plus 1, because you have to go to, you have to do like this. It is the 3 minus sz minus 1. So you decrease it by s1 minus 1 times. So here there should be a bracket, and rest things has, yes. So samples are working. So what if s1 size is greater than s2 size? So in that case, see this example, what if s1 size is greater than the s2 size? So here if you consider this thing, here we are directly checking for the first window. Okay, so we were so here they haven't added that they haven't added that s1 length will be lesser always. So we have to check that case also, because here we are directly iterating over the first window. We are assuming that sz will be always less than equal to n, but this cannot be the case always. So we'll handle that case here only. So if s1 dot size is greater than s2 dot size, then we cannot get an answer, because the s1 is a bigger string. So how can we get a permutation of this in s2? So we'll directly return a false from here. Let us test this again. Yes, so now it is working, and we have improved on both the time complexity and the space complexity. So yes, this is the second optimized solution. And what is the time complexity of this? So this is a sliding window, so every window has been traversed one time. So this loop is nothing but n times, and inside this n times I am only iterating over this map. So this map can be of maximum 26 size. Okay, so this map can be of 26 size. So yes, so it is nothing but your n into 26. Okay, so yes, this is your second solution. So and the space we are not using, like we are using the number of alphabets space. So you can say that it is number of alphabets if you are taking that as a variable, because someone will say that 26 is in English, but whatever, like it can be some other language. So you can take O of number of characters, number of alphabets. Okay, so here if you consider the time complexity, so here you consider the time complexity. The time complexity is nothing but n into number of characters, number of alphabets basically. And the space we are using is equal to like O of number of alphabets basically. So here it is 26. Okay, and this is also big O. So yes, this is the second solution, and it is way better than the first solution where we have this n square thing, n square into log of that number of alphabets. Okay, so yes, this is the second solution. So now we are coming to the final solution, which is exactly similar to the second solution, but now we will be trying to get rid of this number of alphabets. Like every time in every window we are iterating over the map to check whether whether for every character the frequency is same or not. But what we can do instead is, in order to do it, what we can do is, from the previous checking we can take, because in the previous thing we must have iterated over the map and check how many frequencies are matching, so we can make use of that in the current state also. So what we'll do is, suppose there are four characters, A, B, C and D. So if there are four characters A, B, C and D, so what we can do here is, instead of so we will be maintaining one variable which will be equal to need kind, which will, suppose, let us name it as equal count. Okay, equal count. So this equal count will store how many character frequencies are same. Okay, suppose in MP this is having a frequency 4 and in MP sub this is having a frequency 3, so it is not equal. For this B, in MP we are having a frequency 2 and in MP sub also we are having a frequency 2. Suppose here it is 1, here it is 1 and here it is 3 and here it is 2. So then the equal count will be equal to this one and this one. Okay, for these two there are same frequency, so it will be equal to 2 here. And when this equal count will become equal to the MP size, that means for all the characters frequencies are matching, so we'll get a valid string after that. Okay, so this is what we will be maintaining, how many characters, for how many characters the frequencies are matching. So how to do it? So see, the first part of the code will remain same. This is the edge case that we have to take care. Then MP we have to make, then this MP we are making, then N, then S set. So this is the same sliding window technique, just we are optimizing over that. Okay, so this is the first window you have to check. Okay, first window you have to check, and instead of this check we'll have one variable equal count, which will store how many character frequencies are same. So here what we'll do is, if it is equal, then we'll increase the equal count plus plus. And here if this equal count becomes equal to the map dot size, then we'll say map dot size is the total number of characters which we have to check. Okay, and this equal count is how many characters the frequencies are matching. So if it is equal, then we'll say that yes, all character frequencies are matching, so we are done basically. So then we'll slide the window and then let us see what. So here we were just adding in this map sub, and map sub we were removing directly, but here now we cannot do this. Okay, so this thing will change and let us see how we'll change this. So see, what will happen is, there may be few cases we have to analyze. So let us first do the addition part. Okay, so if we do the addition part means that the map, in the map sub we will be adding this thing, right? But in order to add also, while adding also, we have to consider this equal count. Like equal count, what is the impact in this equal count if we do this, like if we increase the frequency of that particular character. Okay, so what is that character? First take that character, the end character, into consideration. So end character is nothing but S2 of end. So see, there may be the case where in map, suppose this end character is a A, this A frequency of this A in map currently before adding this end character is 4, and in map sub also it is 4. So here it, like in the equal count variable, this would have added a 1 because these frequencies are equal. Okay, it would have added a 1. So what we have to do, if now we are adding a, so what will happen? In the map its frequency remains the same, but in the map sub its frequency will become 5. So now it is not equal. Okay, so now it is not equal. So what should we do here? In this case, if we are moving from equal count to not equal count, basically earlier for this A it was equal, but now it is not equal. So in the equal count we were having this 1 for this particular A, like equal count is having a 1 for every character. Okay, for B also, if the frequency is equal, we must have added a 1 in the previous state. So what we'll do is, if MP of end char, this is before adding, is equal to MP2 of end char, then we'll do equal count minus minus, because earlier it was equal 4 4, but now we are making it 4 5. So now we are making it unequal, so the equal count will reduce. So this is that. So before adding in the MP, this is not MP2, MP sub, before adding in the MP sub, we'll check that if earlier it was equal or not. If earlier it was equal, then this equal count will decrease. Now we'll add it. Okay, so MP sub of end char plus plus. So now we have added A to the MP sub. There may be the case that now we have to check after adding. Suppose the MP was 4 and in MP sub we were having a 3, but now since we have added, so MP has become 4 and now MP sub has become 4. So what will happen if MP of end char is equal to MP sub of end char? So now we'll do equal count plus plus, because we have found one more character whose frequency has become equal. So this is the addition part. Okay, so we have to take care of two cases, whether earlier it was equal or whether now it is equal. Now we'll do the removal part. So we have to remove which character? So character to remove is nothing but start. I am saying that it is start remove character. Rem character is equal to S2 of start minus 1. Now there may be the case that earlier it is equal. So before removing it is equal. For suppose we are removing a B. So in the map there is a frequency of B was 4, and in the map sub also the frequency is 4. But now since we are removing this, so in the map it is 4 and in the map sub it is 3. So earlier it was equal and now it is unequal. So we have to, before removing, we have to check whether for that character rem character, for this rem character, if it is equal to rem end character, rem's remove character, rem sub. So if earlier it is equal, so now we are changing it, so it is becoming from equal to unequal, so the equal count will decrease. There may be, now we'll add it to the MP sub and remove character plus plus. Now there may be the case that after adding that, like after reducing that, now it becomes equal. Suppose for this B, MP was having 4 and MP sub was having a 5, but now what will happen after removing? Now it becomes equal, so it is nothing but 4 4. So now we have to check that after removal, if MP char equal to MP sub remove character, then you do equal count plus plus. So this is the removal part that we have to take care before removing and after removing, how the frequencies are impacting. So at the end we are done, and we check that whether equal count is equal to mp dot size. Now this mp of size would have changed, because suppose this remaining character is not there in mp. Okay, suppose this remaining character is not there in mp, but we are accessing this mp of remove char, so it will make an entry in the mp. So the number of distinct characters in the mp we cannot use using this mp dot size. So we'll have, so after this loop only, what we'll do is we'll have how many character to check. So we'll have distinct characters that we want. Here we haven't made any change, so it is here we can use mp dot size. Okay, so whenever you are check it with the distinct character. So here also do not check with this, check with distinct character. Here also check how many characters are distinct, and for those we have to add check equal count or not. Okay, so here then maybe you can also add some cases, like if that remaining character is not present in the mp, then do not check this. So we'll see we need that or not. Okay, so here you can do directly return a true, and after this, yes, it is false. So if the equal count is equal to the distinct characters in s1, then you are done. Okay, okay, so here one issue, see, if that particular end character is not there in mp, then do not check, otherwise it may lead to some other wrong cases. So mp dot find that end character, if it is present, is not equal to mp dot end, then only check this. Okay, otherwise no need to check. So here also, then here also, so everywhere you have to check for whether it is there in the mp or not. So it is the remove character, and here also there is a remove character. So first check whether it is there present in mp or not. If it is present, then only check, otherwise no need to check. Yes, so now it works here, and yes, so you don't have to look at this, like I said that this is not that accurate. But yes, now we are done with this optimized, like we have optimized the optimized solution. Okay, so this is the third code, and here if you analyze, the space complexity is the same, we are using a 26 size space. And if you look at the time complexity here, so it is nothing but n times, and now inside this n times we are not looping over, these are all of log 26 operations, because you are using this mp dot find, that is why it is taking, like it is log 26, but you can assume that log 26 as a very small number, and you can also replace this map with a frequency array, so it will not take log of that time. So you can say that now this is kind of 1, and you can say that it is like the time complexity is nothing but O of n, where n is the size of the second string s2, or you can consider it is max of, because for that case we have already handled here. So s2 length will be always greater if you go down, so it is n is nothing but your length of s2, so it is nothing but O of n. So this is the most optimized solution for this, and yes, we have discussed the 3 solutions, and yes, this is the optimized one. So yes, this is it for this video, and if you like the content, please like, share and subscribe to my channel. And if you face any difficulty, feel free to ask in the comment section, and all the links of description, all the links of the solution and the question will be attached in the description. So yes, that's it. See you in the next video.